Hello there, mathletes. Today we have very interesting and very exciting problem. I myself can't wait to solve this. This is actually the hardest problem in the first 50 problems of Project Euler, as the least people have solved this problem. So let's get right into it. It's called Pentagonal Numbers, problem 44. Pentagonal numbers are generated by the formula Pn is equal to n into 3n minus 1 divided by 2. The first 10 pentagonal numbers are 1, 5, 12, 22, 35, 51, 70, 92, 117, 145, and so on. So if you put any number for n is equal to 1, you'll get 1, and for n is equal to 2, you'll get 5, and so on. So you put each number from 1 to any number in consecutive order as they have put it here. That will yield us the pentagonal numbers. Okay, so it can be seen that P4 pentagonal number 4 plus pentagonal number 7 is equal to 22 plus 70 is equal to 92, which yields us another pentagonal number, the eighth one specifically. So the sum of two pentagonal numbers here is getting us another pentagonal number, but their difference, as I mentioned here, however, their difference 70 minus 22 is equal to 48 is not pentagonal, which means that their sum is pentagonal, but their difference is not. So let's see what they're asking us here. Find the pair of pentagonal numbers pj and pk for which their sum and difference are pentagonal, and d is mod pk minus pj is minimized. What is the value of d? So let's really understand this part here. So they want us to find the sum and difference, but they specifically want the difference d, and pk minus pj is in a mod. As let's go over this. J should be greater than k. Okay. So when a number is greater than k, where j is greater than k, we get a larger pentagonal number. So a smaller number minus a larger number will get us a negative number, right? So they have put a mod. I hope you guys know what a mod means. If you put a mod and there's a negative number inside, you get a positive number. It's just the positive distance from the origin or somewhere. Okay, so is minimized. This is the keyword right here. Minimize, so we have to find the minimum difference. So what is the value of d? I have a algebraic formula which we'll go over, and I'll derive it. In our code we are going to put the limit as 10,000, as I think that would be sufficient, as we don't know the answer yet. 10,000 is a very large limit, and we can create a set and a list of pentagonal numbers and check which ones actually is like satisfying our condition. So I'll show you the algebraic formula which I have derived. So the formula given here is Pn is equal to n into 3n 3n minus 1 by 2. Okay, so the formula which I derived here is we have pj and pk, right? And we have to find the difference. So pj is equal to j 3j minus 1, same as the formula which is given there. And similarly pk is equal to k into 3k minus 1 divided by 2. So then please you can pause the video and look at the formula which I derived here. Now we'll go further. So we'll find the difference. Pj minus pk is equal to 3 into j square minus k square. Uh, Let us put this in brackets once again. Then minus j minus k. This is also in brackets. Divide by 2. Wait, this shouldn't be this long. Divide by 2. Okay, so what's the next step, guys? Let's simplify this further. We can do that. 3. As you have done algebra in school, I hope you guys understand what I'm doing right here. We're just using the a square minus b square formula and we're taking things common. That is j minus k we're taking common. Okay, and in the denominator we have 2 again. Uh, Feel free to pause the video and check my derivations. So as we have got the difference pj minus pk, we will take that and evaluate it to the formula which we have here. N into, I'm just writing the step directly, as you guys know that the denominators will get cancelled and the numerators will remain. Okay, this will be equal to 3 into j plus k minus 1 into j minus k divided by 2. I mean, no 2, no divided by 2. Okay, so this is our equation, guys. This is called the Diophantine equation, and but I'll show you two methods to solving this question by using this formula and by using brute force, which is a simpler and faster method. So this is the brute force one. Please pause the video and take a look at this code. I defined Pentagon n, and this is the formula, and I have given limit 10,000, as I have told you guys that 10,000 is enough because I think the Pentagonal number for the index 10,000, it is going to be about like 3 million or 5 million. Uh, okay, so if you're done, I'll show you the code for which I derived the formula. Okay, please feel free to pause the video and take a look at this code. I assume you understood the code. Now let's run this. This will take this will take lesser time as okay. This will take lesser time as we have derived the equation and we have made it easier for the system to get the answer. So this is an easy method. We got difference 5482660. This is our answer, and I also made it mention the numbers j and k. J is 2167 and k is 1020. PJ pentagonal number for j, and pentagonal number for k is this, and the sum is this. Okay, so let's quickly take this answer and check in Project Euler. There you go, guys. We just solved problem 44 from Project Euler, Pentagon numbers. I hope you like my explanation, and stay tuned for more Mathlete Spartan videos. We'll be discovering more math questions and having more math challenges. Thank you.